looking at a method of factoring trinomials when the a value isn't 1, called decomposition. What our goal is in decomposition is to take this middle term, and as the name says, we're going to decompose it into two separate terms so that we can then factor by grouping when we deal with a 4-term polynomial. We're going to start it off very similar to product sum and also very similar to product sum shortcut. I need to find two numbers that add to my middle value, that add to b, and two numbers that multiply to, in this case, a times c. And when I'm saying a, b, and c, I'm referring to the coefficients of my x squared term, my x term, and my constant term, respectively. So in this case, I need to find two values that add to -4 and two values that multiply to the product of 3 times -4. So they're going to need to multiply to -12. So when I'm looking for these values, I'm asking myself, what are some factors of 12? Let me just write this again, -12. And when I think of 12, I'm thinking 6 times 2, I'm thinking 3 times 4, I'm thinking 12 times 1. And the values that are going to work for us this time is 6 and 2. Now, because I'm multiplying to -12, I know that one of these two factors has to be negative. I know that I'm adding to -4, so that's going to tell me that it's the 6 that's negative, right? A -6 plus a +2 still leaves me with -4. And a -6 times +2 still leaves me with a -12 product. So what's going to happen here is I have my polynomial. It's going to stay almost the same, 3x squared. But then I'm going to break up this middle term, this 4x, into a -6x and a +2x, right? Based on those numbers I just found in my table. Again, this is exactly the same value as -4x. I've just split it into two separate parts so that we can do what's known as factoring by grouping. Because all three terms didn't have something in common, if I can split this into 4, I can say, what are those two terms highlighted in blue share? And what are those two terms highlighted in pink share? And because we strategically found these numbers, because we made this product sum chart, we're then going to see that those results also have something in common. So first off, we look at 3x squared minus 6x. These two things have a GCF, a greatest common factor, of a 3 between the 3 and 6, and an x between the x squared and x. So I'm essentially factoring out a 3x. I'm dividing both of these terms by 3x. 3x squared divided by 3x leaves me with just a single x, right? 3 divided by 3 is 1. X squared divided by x is a single x. And then my second term is going to be a -2. -6 divided by 3 gives me -2. And an x divided by an x reduces down to nothing. We're then going to jump ahead, separated as a new term, right? I was dealing with two separate terms that I was factoring, so I'm going to get two separate results. Now I'm asking myself, what do 2x and -4 share? And the most they share is just a factor of 2. So I pull out that factor of 2. I'm dividing it out of each term. I'm left with an x minus 2 inside the brackets. We're going to notice something in common now, right? I essentially went from 4 terms, right? 3x squared minus 6x, 2x, and -4 to 2 terms. I have term 1, right? 3x times x minus 2. Yes, one of the factors is binomial, but this whole thing is considered one term. And then 2 times x minus 2. So now I'm asking myself, now that I have 2 terms, do these 2 terms share anything? And they share this whole bracket of an x minus 2 as a factor, because it's being multiplied into each term. So now I have a greatest common factor of x minus 2. what I'm going to be able to do with this is factor out or divide out x minus 2 out of both terms. Well, when I pull that x minus 2 out of the first term, all I'm left with is a 3x, right? Because that was the only thing being multiplied by x minus 2. And when I pull that x minus 2 out of my second term, all that's left is a positive 2. And so this is our factored form of this trinomial. Let's look at another example. So looking at another example, we're going to look at 2x squared plus 11x plus 12. So again, I'm going to set up my product sum table. I want to make sure I'm finding two values that add to my b, right, that 11 in the middle, the coefficient, and two numbers that multiply to the product of a times c. In this case, it's going to be 24 because I'm doing the 2 times the 12, right, a times c. So I start to think of factors of 24. 24 can be made up of 12 times 2, but neither of those is going to add up to 11, regardless of the signs. It can be 6 times 4, again, is not going to reach 11 for us. However, when I get 8 times 3, if I do a positive 8 plus a positive 3, it gives me positive 11. And when I do a positive 8 times a positive 3, it gives me positive 24. Again, this is now what we're breaking that 11x into. We're decomposing that middle term. I'm going to say that it's now 2x squared plus 8x plus 3x plus 12. All right, I took 11x and I said split it up. But again, while I could split 11 into 5 and 6 or 2 and 9 or a bunch of other options, I chose these strategically so that my factoring, once I do my factoring by grouping, works out to nice numbers. Right? That's why I set up my product sum table. This product sum table helps us find values that will for sure work. I'm then going to group these into pairs, and the easiest way is just to get the pair from the first two and the second two and group those together. So I'm going to be looking at what is the greatest common factor between 2x squared and 8x, and then separately what's the greatest common factor between 3x and 12. Well, 2x squared and 8x share a whole 2x. When I divide 2x squared by 2x, I get just an x. When I divide x by 2x, I get a 4. Then moving on, separate it as a new term, right? Because I'm doing these two things separately. They can't become factors just yet. I see that 3x and 12 share a 3. No variables are shared there. So when I divide 3x by 3, I'm left with just an x. And when I divide 12 by 3, I'm left with a 4. Again, we're always going to notice, hey, these two brackets that I've created are identical. And if they're not, take a look at your signs. Can you factor out a negative? Right? That's usually the number one thing that we're missing, is pulling out a negative. So they both share an x minus 4. Just like I did before, I pull the thing they share out front, right? 2x squared and 8x shared a 2x. So I pulled it out front as a factor and then expressed my next factor as whatever was left after division. Here I pull out that x plus 4 out front. My first factor is left with just a 2x, and my second term is left with just a 3. Again, we can always double check these by distributing again. I would recommend, especially if it was a question you found challenging, go back through, multiply, FOIL, distribute, however you call it, x times 2x, 2x squared, x times 3, we get a 3x, 4 times 2x, we get an 8x, and 4 times 3, we get a 12. So this is my verification. I'm going to verify, right? This is not actually part of the question. I already have my solution, my factored form, but I'm just checking my answer. I'm making sure that I can undo all the steps, go through multiplication, to undo all the division I just did, and make sure it gets me back to where I started. So that is factoring by decomposition.